ability, it seems, to store each of these names pretty straightforwardly. It does literally that, though. It reads all of the lines as is. Well, allow me to turn our attention back to where we left off here, which is just names, to propose that with names.txt, we have an ability, it seems, to store each of these names pretty straightforwardly. But what if we wanted to keep track of other information as well? Suppose that we wanted to store information including a student's name and their house at Hogwarts, be it Gryffindor or Slytherin or something else. Well, where do we go about putting that? You know, Hermione lives in Gryffindor, so we could do something like this in our text file. Harry lives in Gryffindor, so we could do that. Ron lives in Gryffindor, so we could do that. And Draco lives in Slytherin, so we could do that. But I worry here. But I worry now that we're mixing apples and oranges, so to speak. Like some lines are names, some lines are houses. So this probably isn't the best design, if only because it's confusing or it's ambiguous. So maybe what we could do is adopt a convention. And indeed, this is in fact what a lot of programmers do. They change this file not to be names.txt, but instead let me create a new file called names.csv. CSV stands for comma separated values, and it's a very common convention to store multiple pieces of information that are related in the same file. And so to do this, I'm going to separate each of these types of data, not with another new line, CSV. CSV stands for text, but instead let me create a new file called names.csv. CSV stands for comma separated values, and it's a very common convention to store multiple pieces of information that are related in the same file. And so to do this, I'm going to separate each of these types of data, not with another new line, but simply with a comma. I'm going to keep each student on their own line, but I'm going to separate the information about each student using a comma instead. And so now we sort of have a two-dimensional file, if you will. Row by row, we have our students. But if you think of these commas as representing a column, even though it's not perfectly straight because of the lengths of these names, it's a little jagged, you can think of these commas as representing a column. And it turns out these CSV files are very commonly used when you use something like Microsoft Excel, Apple Numbers, or Google Spreadsheets, and you want to export the data to share with someone else as a CSV file. Or conversely, if you want to import a CSV file into your preferred spreadsheet software like Excel or Numbers or Google Spreadsheets, you can do that as well. So CSV is a very common, very simple text format that just separates values with commas and different types of values ultimately with new lines as well. Let me go ahead and run code of students.csv to create a brand new file that's initially empty, and we'll add to it those same names, but also some other information as well. So if I now have this new file, students.csv, inside of which is one column of names, so to speak, and one column of houses, how do I go about changing my code to read not just those names, but also those names and houses so that they're not all on one line? We somehow have access to both type of value separately. Well, let me go ahead and create a new program here called students.py. And in this program, let's go about reading not a text file per se, but a specific type of text file, a CSV, a comma separated values file. And to do this, I'm going to use similar code as before. I'm going to say with open quote unquote students.csv. I'm not going to bother specifying quote unquote r, because again, that's the default. But I'm going to give myself a variable name of file. And then in this file, I'm going to go ahead and do this. For line in file as before. And now I have to be a bit clever here. Let me go back to students.csv, looking at this file, and it seems that on my loop, on each iteration, I'm going to get access to the whole line of text. I'm not going to automatically get access to just Hermione or just Gryffindor. Recall that the loop is going to give me each full line of text. So logically, what would you propose that we do inside of a for loop that's reading a whole line of text at once, but we now want to get access to the individual values, like Hermione and Gryffindor, Harry and Gryffindor? How do we go about taking one line of text and gaining access to those individual values, do you think? Just instinctively, even if you're not sure what the name of the functions would be.
You can access it as you would as if you were using a dictionary, like using a key and value.
So ideally, we would access it using a key and value. But at this point in the story, all we have is this loop. And this loop is giving me one line of text at a time. I'm the programmer now. I have to solve this. There is no dictionary yet in question. How about another suggestion here?
So you can somehow split the two words based on the comma.
Yeah, even if you're not quite sure what function is going to do this, intuitively you want to take this whole line of text, Hermione, comma, Gryffindor, Harry, comma, Gryffindor, and so forth, and split that line into two pieces, if you will. And it turns out wonderfully the function we'll use is actually called split that can split on any characters, but you can tell it what character to use. So I'm going to go back into students.py, and inside of this loop, I'm going to go ahead and do this. I'm going to take the current line. I'm going to remove the white space at the end, as always, using rstrip here. And then whatever the result of that is, I'm going to now call split and quote unquote comma. So the split function or method comes with strings, strs in Python. Any str has this method built in. And if you pass in an argument like a comma, what this split function will do is split that current string into 1, 2, 3, maybe more pieces by looking for that character again and again. Ultimately, split is going to return to us a list of all of the individual parts to the left and to the right of those commas. So I can give myself a variable called row here. And this is a common paradigm. When you know you're iterating over a file, specifically a CSV, it's common to think of each line of it as being a row. And each of the values therein, separated by commas, as columns, so to speak. So I'm going to deliberately name my variable row, just to be consistent with that convention. And now what do I want to print? Well, I'm going to go ahead and say this. Print, how about the following? An f string that starts with curly braces. Well, how do I get access to the first thing in that row? Well, the row is going to have how many parts? 2. Because if I'm splitting on commas, and there's 1 comma per line, that's going to give me a left part and a right part, like Hermione and Gryffindor, Harry and Gryffindor. When I have a list like row, how do I get access to individual values? Well, I can do this. I can say row, bracket, 0. And that's going to go to the first element of the list, which should hopefully be the student's name. Then after that, I'm going to say is in, and I'm going to have another curly brace here for row bracket 1. And then I'm going to close my whole quote. So it looks a little cryptic at first glance, but most of this is just f-string syntax with curly braces to plug in values. And what values am I plugging in? Well, row, again, is a list, and it has 2 elements, presumably. Hermione in one and Gryffindor in the other, and so forth. So bracket 0 is the first element, because remember, we start indexing at 0 in Python, and 1 is going to be the second element. So let me go ahead and run this now and see what happens. Python of students.py, enter, and we see Hermione's in Gryffindor, Harry's in Gryffindor, Ron is in Gryffindor, and Draco is in Slytherin. So we have now implemented our own code from scratch that actually parses, that is, reads and interprets a CSV file ultimately here. Now let me pause to see if there's any questions, but we'll make this even easier to read in just a moment. Any questions on what we've just done here by splitting by comma?
So my question is, can we edit any line of code anytime we want, or the only option that we have is to append the lines? Or let's say if we want to, let's say, change Harry's house to, let's say, Slytherin or some other house.
Yeah, a really good question. What if you want to, in Python, change a line in the file and not just append to the end? You would have to implement that logic yourself. So for instance, you could imagine now opening the file and reading all of the contents in, then maybe iterating over each of those lines. And as soon as you see that the current name equals Harry, you could maybe change his house to Slytherin. And then it would be up to you, though, to write all of those changes back to the file. So in that case, you might want to, in simplest form, read the file once and let it close, then open it again, but open for writing and change the whole file. It's not really possible or easy to go in and change just part of the file, though you can do it. It's easier to actually read the whole file, make your changes in memory, then write the whole file out. But for larger files where that might be quite slow, you can be more clever than that. Well, let me propose now that we clean this up a little bit, because I actually think this is a little cryptic to read, row bracket 0, row bracket 1. It's not that well written at the moment, I would say. But it turns out that when you have a variable that's a list, like row, you don't have to throw all of those variables into a list. You can actually unpack that whole sequence at once. That is to say, if you know that a function like split returns a list, but you know in advance that it's going to return two values in a list, the first and the second, you don't have to you can be more clever than that. Well, let me propose now that we clean this up a little bit, because I actually think this is a little cryptic to read, row bracket 0, row bracket 1. It's not that well written at the moment, I would say. But it turns out that when you have a variable that's a list, like row, you don't have to throw all of those variables into a list. You can actually unpack that whole sequence at once. That is to say, if you know that a function like split returns a list, but you know in advance that it's going to return two values in a list, the first and the second, you don't have to throw them all into a variable that itself is a list. You can actually unpack them simultaneously into two variables, doing name, comma, house. So this is a nice Python technique to not only create but assign automatically in parallel two variables at once, rather than just one. So this will have the effect of putting the name in the left, Hermione, and it will have the effect of putting Gryffindor, the house, in the right variable. And we now no longer have a row. We can now make our code a little more readable by now literally just saying name down here and, for instance, house down here. So just a little more readable, even though functionally the code now is exactly the same. All right, so this now works, and I'll confirm as much by just running it once more. Python of students.py, enter, and we see that the text is as intended. But suppose for the sake of discussion that I'd like to sort this list of output. I'd like to say hello again to Draco first, then hello to Harry, then Hermione, then Ron. How can I go about doing this? Well, let's take some inspiration from the previous example where we were only dealing with names and instead do it with these full phrases. So-and-so is in house. Well, let me go ahead and do this. I'm going to go ahead and start scratch and give myself a list called students, equal to an empty list initially. And then with open students.csv as file, I'm going to go ahead and say this. For line in file. And then below this, I'm going to do exactly as before. Name, comma, house equals the current line, stripping off the white space at the end, splitting it on a comma. So that's exact same as before. But this time, before I go about printing the sentence, I'm going to store it temporarily in a list so that I can accumulate all of these sentences and then sort them later. So let me go ahead and do this. Students, which is my list, dot append. Let me append the actual sentence I want to show on the screen. So another F string. So name is in house, just as before. But notice I'm not printing that sentence. I'm appending it to my list. Not a file, but to my list. Why am I doing this? Well, just because, as before, I want to do this. For student in the sorted students, I want to go ahead and print out student, like this. Well, let me go ahead and run Python of students.py and hit enter now, and I think we'll see. Indeed, Draco is now first, Harry is second, Hermione is third, and Ron is fourth. But this is arguably a little sloppy, right? It seems a little hackish that I'm constructing these sentences. And even though I'm technically want to sort by name, I'm technically sorting by these whole English sentences. So it's not wrong. It's achieving the intended result. But it's not really well designed because I'm just kind of getting lucky that English is reading from left to right. And therefore, when I print this out, it's sorting properly. It would be better, really, to come up with a technique for sorting by the students' names, not by some English sentence that I've constructed here on line 6. So to achieve this, I'm going to need to make my life more complicated for a moment. And I'm going to need to collect information about each student before I bother assembling that sentence. So let me propose that we do this. Let me go ahead and undo these last few lines of code so that we currently have two variables, name and house, each of which has name and the student's house respectively. And we still have our global variable students. But let me do this. Recall that Python supports dictionaries. And dictionaries are just collections of keys and values. So you can associate something with something else, like a name with Hermione, like a house with Gryffindor. That really is a dictionary. So let me do this. Let me temporarily create a dictionary that stores this association of name with house. Let me go ahead and do this. Let me say that the student here is going to be represented initially by an empty dictionary. And just like you can create an empty list with square brackets, you can create an empty dictionary with curly braces. So give me an empty dictionary that will soon have two keys, name and house. How do I do that? Well, I could do it this way. Student, open bracket, name, equals the student's name that we got from the line. Student bracket house equals the house that we got from the line. And now I'm going to append to the students list, plural, that particular student. Now, why have I done this? I've admittedly made my code more complicated. It's more lines of code. But I've now collected all of the information I have about students while still keeping track. What's a name? What's a house? The list, meanwhile, has all of the students' names and houses together. Now, why have I done this? Well, let me, for the moment, just do something simple. Let me do for student in students, and let me very simply now say print the following f string. The current student with this name is in this current student's house. And now notice one detail. Inside of this f string, I'm using my curly braces as always. I'm using inside of those curly braces the name of a variable, as always. But then I'm using not bracket 0 or 1, because these are dictionaries now, not list. But why am I using single quotes to surround house and to surround name? Why single quotes inside of this f string to access those keys?
Yes, because you have double quotes in that line 12, and so you have to tell Python to differentiate.
Exactly. Because I'm already using double quotes outside of the f string, if I want to put quotes around any strings on the inside, which I do need to do for dictionaries, because recall, when you index into a dictionary, you don't use numbers like lists, 0, 1, 2, onward. You instead use strings, which need double quotes outside.
So you have double quotes in that line 12, and so you have to tell Python to differentiate.
Exactly. Because I'm already using double quotes outside of the f string, if I want to put quotes around any strings on the inside, which I do need to do for dictionaries, because recall, when you index into a dictionary, you don't use numbers like lists, 0, 1, 2, onward. You instead use strings, which need to be quoted. But if you're already using double quotes, it's easiest to then use single quotes on the inside so Python doesn't get confused about what lines up with what. So at the moment, when I run this program, it's going to print out those hellos, but they're not yet sorted. In fact, what I now have is a list of dictionaries. Nothing is yet sorted, but let me tighten up the code too to point out that it doesn't need to be quite as verbose. If you're in the habit of creating an empty dictionary, like this on line 6, and then immediately putting in two keys, name and house, each with two values, name and house respectively, you can actually do this all at once. So let me show you a slightly different syntax. I can do this. Give me a variable called student, and let me use curly braces on the right-hand side here. But instead of leaving them empty, let's just define those keys and those values now. Quote unquote name will be name, and quote unquote house will be house. This achieves the exact same effect in one line instead of 3. It creates a new non-empty dictionary containing a name key, the value of which is the student's name, and a house key, the value of which.
We open it up. We sift through it for every line in the file, so then it reads through all those. We go ahead and we strip the white space, split it, then we create a dictionary and we say name. Let's take that, we attach a key and a value to it, or forget which one's the key. But key and value is within both of those, so now ID is ID from here, and then name is name. And then we append user into here, and then we say for user and users print. Okay.
Is the student's house. Nothing else needs to change. That will still just work, so that if I again run python of students.py, I'm still seeing those greetings, but they're still not quite actually sorted. Well, what might I go about doing here in order to, what could I do to improve upon this further? Well, we need some mechanism now of sorting those students. But unfortunately, in order to, what could I do to improve upon this further? Well, we need some mechanism now of sorting those students. But unfortunately, you can't do this. We can't sort all of the students now because those students are not names like they were before. They aren't sentences like they were before. Each of the students is a dictionary, and it's non-obvious how you would sort a dictionary inside of a list. So ideally, what do we want to do? If at the moment we hit line 9, we have a list of all of these students, and inside of that list is one dictionary per student, and each of those dictionaries has 2 keys, name and house. Wouldn't it be nice if there were a way in code to tell Python, sort this list by looking at this key in each dictionary? Because that would give us the ability to sort either by name or even by house or even by any other field that we add to that file. So it turns out we can do this. We can tell the sorted function not just to reverse things or not. It takes another named parameter called key, where you can specify what key should be used in order to sort some list of dictionaries. And I'm going to propose that we do this. I'm going to first define a function temporarily for now called getName. And this function's purpose in life, given a student, is to quite simply return the student's name from that particular dictionary. So if student is a dictionary, this is going to return literally the student's name. And that's it. That's the sole purpose of this function in life. What do I now want to do? Well, now that I have a function that, given a student, will return to me the student's name, I can do this. I can change sorted to say, use a key that's equal to whatever the return value of getName is. And this now is a feature of Python. Python allows you to pass functions as arguments in 2 other functions. So getName is a function, sorted is a function, and I'm passing in getName to sorted as the value of that key parameter. Now, why am I doing that? Well, if you think of the getName function as just a block of code that will get the name of a student. That's handy because that's the capability that sorted needs. When given a list of students, each of which is a dictionary, sorted needs to know, how do I get the name of the student in order to do alphabetical sorting for you? The authors of Python didn't know that we were going to be creating students here in this class, so they couldn't have anticipated writing code in advance that specifically sorts on a field called student, let alone called name, let alone house. So what did they do? They instead built into the sorted function this named parameter key that allows us, all these years later, to tell their function sorted how to sort this list of dictionaries. So now watch what happens. If I run Python of students.py and hit enter, I now have a sorted list of output. Why? Because now that list of dictionaries has all been sorted by the student's name. I can further do this. If, as before, we want to reverse the whole thing by saying reverse equals true, we can do that too. Let me rerun Python of students.py and hit enter. Now it's reversed. Now it's Ron, then Hermione, Harry, and Draco. But we can do something different as well. What if I want to sort, for instance, by house name reversed? I could do this. I could change this function from getName to getHouse. I could change the implementation up here to be getHouse. And I can return not the student's name, but the student's house. And so now, notice, if I run Python of students.py, enter, notice now it is sorted by house in reverse order. Slytherin is first, and then Gryffindor. If I get rid of the reverse, but keep the getHouse and rerun this program, now it's sorted by house. Gryffindor is first, and Slytherin is last. And the upside now of this is because I'm using this list of dictionaries and keeping the students' data together until the last minute when I'm finally doing the printing, I now have full control over the information itself, and I can sort by this or that. I don't have to construct those sentences in advance like I rather hackishly did the first time. All right, that was a lot. Let me pause here to see if there are questions.
So when we're sorting the files, should we every time should we use the loops, or like a dictionary or any kind of list? Can we sort by just sorting, not looping or any kind of stuff?
A good question. And the short answer with Python alone, you're the programmer, you need to do the sorting. With libraries and other techniques, absolutely. You can do more of this automatically because someone else has written that code. What we're doing at the moment is doing everything from scratch ourselves. But absolutely, with other functions or libraries, some of this could be made more easily done. Some of this could be made easier. Other questions on this technique here?
It equal to the returned value of the function. Can it be equal to just a variable or a value?
Well, yes, it should equal a value. So I'm specific, and I should clarify actually, since this was not obvious. So when you pass in a function like getName or getHouse to the sorted function as the value of key, that function is automatically called by the sorted function for you on each of the dictionaries in the list. And it uses the return value of getName or getHouse to decide what strings to actually use to compare in order to decide which is alphabetically correct. So this function, which you pass just by name, you do not pass in parentheses at the end, is called by the sorted function in order to figure out for you how to compare these same values.
How can we use nested dictionaries? يعني I have read about nested dictionaries. What is the difference between nested dictionaries and dictionary inside a list? I think it is.
Sure. So we are using a list of dictionaries. Why? Because each of those dictionaries represents a student, and a student has a name and a house, and we want to, I claim, maintain that association. And it's a list of students because we've got multiple students, 4 in this case. You could create a structure that is a dictionary of dictionaries, but I would argue it just doesn't solve a problem. I don't need a dictionary of dictionary. I need a list of key value pairs right now. That's all. So let me propose if we go back to students.py here, and we revert back to the approach where we have getName as the function, both used and defined here, and that function returns the student's name. What happens to be clear is that the sorted function will use the value of key, getName in this case, calling that function on every dictionary in the list that it's supposed to sort. And that function getName returns the string that sorted will actually use to decide whether things go in this order, left, right, or in this order, right, left. It alphabetizes things based on that return value. Left pi here, and that's solvable. Could create a structure that is a dictionary of dictionaries, but I would argue it just doesn't solve a problem. I don't need a dictionary of dictionary. I need a list of key value pairs right now. That's all. So let me propose if we go back to students.py here, and we revert back to the approach where we have getName as the function, both used and defined here, and that function returns the student's name. What happens to be clear is that the sorted function will use the value of key, getName in this case, calling that function on every dictionary in the list that it's supposed to sort. And that function getName returns the string that sorted will actually use to decide whether things go in this order, left, right, or in this order, right, left. It alphabetizes things based on that return value. So notice that I'm not calling the function getName here with parentheses. I'm passing it in only by its name so that the sorted function can call that getName function for me. Now, it turns out, as always, if you're defining something, be it a variable or in this case a function, and then immediately using it, but never once again needing the name of that function, like getName, we can actually tighten this code up further. I can actually do this. I can get rid of the getName function altogether, just like I could get rid of a variable that isn't strictly necessary. And instead of passing key, the name of a function, I can actually pass key what's called a lambda function, which is an anonymous function, a function that just has no name. Why? Because you don't need to give it a name if you're only going to call it in one place. And the syntax for this in Python is a little weird, but if I do key equals literally the word lambda, then something like student, which is the name of the parameter I expect this function to take, and then I don't even type the return key. I instead just say student bracket name. So what am I doing here with my code? This code here that I've highlighted is equivalent to the getName function I implemented a moment ago. The syntax is admittedly a little different. I don't use def. I didn't even give it a name like getName. I instead am using this other keyword in Python called lambda, which says, hey, Python, here comes a function, but it has no name. It's anonymous. That function takes a parameter. I could call it anything I want. I'm calling it student. Why? Because this function that's passed in as key is called on every one of the students in that list, every one of the dictionaries in that list. What do I want this anonymous function to return? Well, given a student, I want to index into that dictionary and access their name so that the string Hermione and Harry and Ron and Draco is ultimately returned. And that's what the sorted function uses to decide how to sort these bigger dictionaries that have other keys like house as well. So if I now go back to my terminal window and run python of students.py, it still seems to work the same, but it's arguably a little better designed because I didn't waste lines of code by defining some other function, calling it in one and only one place. I've done it all sort of in one breath, if you will. All right, let me pause here to see if there's any questions specifically about lambda or anonymous functions and this tightening up of the code.
And I have one question, like whether we could define lambda twice.
You can use lambda twice. You can create as many anonymous functions as you'd like, and you generally use them in contexts like this where you want to pass to some other function a function that itself does not need a name. So you can absolutely use it in more than one place. I just have only one use case for it. How about one other question on lambda or anonymous functions specifically?
What if our lambda would take more than one line, for example?
Sure, if your lambda function takes multiple parameters, that is fine. You can simply specify commas followed by the names of those parameters, maybe x and y or so forth, after the name student. So here too, lambda looks a little different from def in that you don't have parentheses, you don't have the keyword def, you don't have a function name, but ultimately they achieve that same effect. They create a function anonymously and allow you to pass it in, for instance, as some value here. So let's now change students.csv to